Hi, my name is William Field and I am a member of Team 9 for Dr. Tosunoglu's Mechanical Design 1 Summer A class, and our report is on the evolution of medical robots. I'm going to start with an introduction of medical robots, and a good definition for it would be a robotic device that allows for increased precision and decreased invasion during medical procedures. And to begin with, we're going to talk a little bit about the background of medical robots and their history. There are several subsets of these medical robots that are used for different tasks in the surgical room, and these will include biorobots, rehabilitation robots, and disinfection robots. And the main purposes of each of these robots would be to distance the surgeon from the operating table, to aid patients after the surgery, and to keep the surgical area sterile and clean. The first surgical robot was seen in 1985. That was the big step in the evolution. This first robot was called the Puma 560 and was used to place a needle in a brain biopsy procedure. However, this robot did not see much surgical use later on in the future because the medical field was not yet comfortable with having the surgeon so far away from the operating table. The big period of growth would be the 1990s, and this saw leaps in telepresence surgery and prosthetic limbs. You can see the biggest improvement in this area was the creation of the Da Vinci system, which we'll talk a little bit about later. But at this point in time, it is so powerful that it can sew the skin back onto a grape. A little bit about the literature survey. One of the main issues prior to medical robots was that it could take almost 10 to 12 personnel to complete even a minor surgery in a hospital. And one of the benefits of having the robots was that it would mean there was a decreased number of people in the operating room, people had more room to work, and there was less room for error. Again, there was an increased precision and smaller incisions during the surgeries, which would eventually lead to reduced recovery time for patients. Again, surgeries performed from a distance was a huge improvement, and it opened the doors for the use of consoles to operate these mechanical robots, so the surgeon could do it from a distance. And this would open doors for wartime aid and disaster relief in case the surgeon was not able to be at the operating table or at the location of injury at any given point in time. Some of the major stepping stones for the evolution of medical robots can be divided into several dates, the first of which we discussed earlier was 1985 and the introduction of the Puma 560 with the brain biopsy. This one was considered the first real medical robot. The next big step could be 1988 when Dr. Friedrich Wilhelm Mohr, he performed the first heart bypass surgery in the United States at the German Leipzig Heart Center. Next, in 2000, was a big step when the Da Vinci robot, which we discussed earlier, became the first robot to acquire FDA approval. This robot has 4 mechanical arms that are all controlled through a master console by a surgeon at whatever distance as far as the console can communicate with the robot. In 2006, the first quote-unquote unmanned robot was used, and this robot was so powerful that it yielded the results of an above-average surgeon, which means that it was doing better than a lot of surgeons would be able to do in person. 2010 was they had the establishment of what they considered the first true robot, which meant that it was no longer mirroring a surgeon's movements on a console through toggle sticks or through anything like that, but rather it was through buttons. So the medical robot was already programmed to do certain tasks, and by a press of a button, the surgeon could have it perform that task. And
my name is Adam Wexler, and I will be discussing our design alternative. Our design is for a disinfection robot. It has the capabilities of autonomous locomotion. It is capable of moving on its own, and also ultraviolet germicidal radiation, or UVGI. UVGI utilizes short-wave ultraviolet C radiation in order to kill or inactivate microbes by damaging their DNA. The main components of our robot include the base, located at the bottom. The base houses the motor and wheels and allows for the locomotion of our robot. At the very top, you see the dome. The dome houses a camera that is used for remote-controlled steering. The dome also houses motion sensors in order to detect the presence of any people in the vicinity. The bright blue UV-GI bulbs emit the shortwave UV radiation. Our robot possesses the following autonomous capabilities. It includes automatic shutdown whenever motion is detected. UV radiation is not dangerous to humans in short doses, but you do want to avoid prolonged exposure. Therefore, if motion is detected, the UV-GI bulbs will shut down automatically. Also, the sensors at the bottom are capable of preparing planned locomotion to make sure it covers the entire floor plan, as well as obstacle avoidance, such as obstacles situated around the floor and sudden drops, such as stairs. Our robot possesses remote control capabilities. It can be scheduled remotely, and it can also be activated remotely. And using the camera situated in the dome and the motor in the base, it can be steered remotely. The primary utilizations for our robot would include unoccupied buildings, such as medical research centers or schools, any place where you can be assured that the building will be empty and doors can be left open for several hours at a time. We would not recommend our robot be used in a hospital. Hospitals are occupied 24 hours a day typically, and therefore hospitals actually have a similar device that they use. It looks like our device, but does not possess the capability for locomotion. Instead, a person manually will wheel the device into a room, shut the doors to the room, and then remotely activate the UV-GI bulbs. We would also recommend that our device be used in hot zones, any place where a hazmat suit may not be available or its use may be considered unnecessarily dangerous.
My name is Arturo Garcia, and I'm going to be talking about the design experience. Advances in technology, they seem to have only positive impact on today's society, since machines and robots, they are improving our life in almost every aspect of it. Employers, governments, employees, and companies, they are implementing robots in their job, replacing humans with robots all around the world. As we can see when we use ATMs, automated tolls, and vending machines. Automated machines and robots, they are all also being implemented on the medical and health area. Robots as the Da Vinci robot, which is a robot that performs surgeries. Care support robots like the Toyota's independent walking assistant, which is a robot that helps people with disabilities to carry out almost any activity without help of anyone. And hospital assistant as the Atheon TOG, which is basically a robot that takes medicine from a room to another room inside the hospital. We cannot forget that at the end these are robots, and robots, they can't think by themselves and they can't make decisions. And that's where the real problem begins. And that is without mentioning the malfunction that can arise at any time when we're using a robot. I'm going to cite the example of the Da Vinci robot, which is, I think, the most important example to be cited, now that it's the best robot to perform surgeries in these days. Database reports at least 85 deaths and 25 injuries because of this robot. And this is because when performing a surgery, sometimes organs can be stabbed or be burned, and the doctor who's carrying out this surgery, he will notice because of what they call the lack of haptic feedback, which is the lack of tactile feel, and that's very important at the time of performing a surgery. About the negative outcomes, robots are leaving people without their jobs since they are being replaced by them. Since we are so focused on developing new technologies, we are not worrying about the possible outcomes of it. And standards and procedures must be changed because of that. And last but not least is that since these are robots, they require maintenance and energy, which is equals time and money.